So this week we're going to do finding the nth term by using finite differences. And it's a pretty straightforward technique. It gets a little tedious, but the technique, the idea behind it is actually really simple. So I'm just going to go ahead and let me pull out my list here. Let's say we're just going to start off with an example. It's better done with an example. So find the nth term for this sequence. And it's -2, -4, -4, -2, 2, 8, 16, 26, and so on and so on. So you look at it and always double check and see if it's arithmetic or geometric first, because if it is, much easier. To go from the first term to the second term, let's see, if it was arithmetic, we would be decreasing by 2, so we would add a -2. But if we add a -2 to the second term, we don't get the third term. Okay, not arithmetic. Is it geometric? Well, we could multiply -2 by 2 and get -4, but -4 times 2 is not -4. Okay, not geometric either. Rats. Now, you could play around with it and try to figure it out, or you can try finite differences. So here's how it works. So like the name implies, it's going to involve differences. So you take two consecutive terms and subtract them. But the order matters. It's always got to be the second term minus the first term. So for instance, actually let me change colors. For these first two terms, -4 minus -2 is -2. Then the next two terms, -4 minus -4 is 0. And then the next two terms, -2 minus -4 is +2. And you just keep this up. 2 minus -2 is 4. 8 minus 2 is 6. 16 minus 8 is 8. And the last pair that we have to work with is 26 minus 16 is 10. And you probably noticed a nice pattern in these numbers down here. And what you're looking for, though, is these numbers to get constant. They're not constant yet. So although there's a nice pattern, they're not constant. So subtract them again. Do the same exact process. Take two consecutive numbers and do the second one minus the first one. So 0 minus -2 is 2. 2 minus 0 is 2. 4 minus 2 is 2. Now we're getting that constant. 6 minus 4 is 2. 8 minus 6 is 2. 10 minus 8 is 2. So each level we have a difference. This first level is called the first difference. Excuse me. The second one is the second difference. And like I said, you're looking for where it's going to get constant. And it happened at the second differences. The second differences became constant. So what that implies, second differences are constant. So that implies that a sub n is a second degree polynomial. And then that gives us something to work with. Now we know what kind of thing we're looking for. So the key is whatever difference you've got that's constant, that's the degree of the polynomial. So if you can find finite differences that are constant, you have a polynomial expression for a sub n. Okay, so what does that really mean? I mean, we kind of have an idea now about a sub n, but how do we actually find that polynomial? And sometimes, very rarely though, but sometimes it's enough just to know that, and then you can look at it and go, oh yeah, now I see what it is. I don't know about you guys, I can't look at that and see what that is. But we can make a system of equations. So if a sub n is a second degree polynomial, then we know that a sub n, has to be of this form. an squared plus bn plus c. And I like to use capital letters here because it doesn't get mixed up with any other variable that we're using in the problem. But a sub n is going to look something like this. This is a second degree polynomial. I just need to find the values for a, b, and c. All right. So how do we find those values? Well, system of equations. We have 3 unknowns we're trying to find, so we need 3 equations to do that with. So if we take a look, you can use any ones you want, but to keep the numbers the smallest, it's going to be easiest to do the first 3 terms. So here's how it works. From the first term, we know that n equals 1, that's the first term, and that a sub n would be negative 2. So when n is 1, the first term, a sub 1, is the first term here, which is negative 2. So that gives us this equation. We're basically going to plug in negative 2 for a sub n, and we're going to plug in a 1 for all of these n's. So when we do that, plug in the negative 2 in for a sub n, and then that equals a times 1 squared plus b times 1 plus c, or just negative 2 equals a plus b plus c. And then we're going to do that for the first 3 terms to get our first 3 equations. So for the second term, we're looking when n equals 2, that second term, we can look up there and see the second term is negative 4. And so again, plugging in negative 4 to a sub n and the 2 for these n's, we're going to get negative 4 equals a times 2 squared plus b times 2 plus c, or negative 4 equals 4a plus 2b plus c. And then we do it one more time. For the third term, when n equals 3, that third term is also negative 4. So a sub n is negative 4 when the n's are 3. So we plug in the 3 for all the n's, and we get negative 4 equals 9a plus 3b plus c. And these are the 3 equations that are going to make up our system of equations to solve. So we're going to solve it, and I'm going to do it. I'm going to do it one way here, which is probably a way that you guys are familiar with. But I'm going to make a separate video for another technique. It's called Gauss elimination. And it's actually, when you get the hang of it, it's super efficient to solve systems of equations. And this was not so bad. A sub n is a quadratic. It was a secondary because the second differences were constant. Can you imagine if this was a third degree? We would have an extra variable, which means we'd have to have 4 equations. Becomes much more of a nightmare to solve without something like Gauss. So like I said, I'm going to go ahead and solve this one the good old-fashioned way that you guys are familiar with, but I am going to make a separate video so you guys can see how Gauss works. But for this one, just to remind us how this works, so our system of equations then is negative 2 equals a plus b plus c, negative 4 equals 4a plus 2b plus c, and negative 4 equals 9a plus 3b plus c. So now it just becomes solving this equation, or this system, I mean. So I'm going to label these equation 1, equation 2, equation 3. Let's go ahead and subtract equations 1 and 2 together. So we got equation 1 and equation 2. Equation 1 was negative 2 equals a plus b plus c. Equation 2 is negative 4 equals 4a plus 2b plus c. If we subtract them, that'll get the c's to cancel out. Let's see, we're going to get positive 2 equals negative 3a minus b. Like I said, the c's are gone. And then I'll do equation 2 and 3. You can do them in whatever you want, but the key is I'm going to take two of the equations and eliminate c. And I'm going to take another pair and eliminate c. That way I'm going to get a system of 2 equations with 2 unknowns and combine it there. This is where the tedious part comes in. So there's equation 2. Equation 3 is that. We're going to subtract the two equations. We're going to get 0 on the left, negative 5a minus b on the right. So I'm going to call that one equation 4 and this one equation 5. And we're going to combine these guys. And if we just subtract them, the b's will cancel out and we can solve for a. Yay! So I'm going to put equation 4 here and then equation 5. And 2 equals negative 3a minus b. 0 equals negative 5a minus b. Again, I will subtract them. And I get 2 equals 2a. So 1 equals a. Yay! I know that one. And then it's just a matter of back substitution. I can take this value for a and plug it into equation 5 or 4. Doesn't matter. I'll be able to find b. And then I always like to go back to equation 1 because it's nice and simple. And find c. So let's say we'll plug into... Let's just do equation 5 because of that 0. Seems like that'll make life easier. So 0 is, a is 1, so it's negative 5 times 1. So it's just going to be negative 5 minus b. And so b is negative 5. We got that one. And then we're going to plug into equation 1. And we have a little record of what equation 1 was right here. So negative 2 is a, which is 1, plus b, which is negative 5, plus c. So negative 2 is negative 4 plus c, so c is 2. And now I have everything we need. We have a, we have b, we have c. We can go back to this form right here and plug in the value for a, b, and c, and we'll have our equation. So remember, I'm just going to put it over here so I can fit this on one page. We were working with this, but now we know that a is 1, so it's going to be n squared. B, was negative 5, so I'm going to say minus 5n, and c was positive 2, and we have it. There you go. You basically have enough to get started now. That's all there is to this. I'm just going to set up one more problem, but honestly, if you want, you could probably stop right here and do the homework. Look at that, it fits on one page. Just a quick recap. So again, you're given the sequence. You want to find a formula for the nth term. You notice it's not arithmetic or geometric, so we don't have those other formulas to fall back on. So the only other strategy we have, besides just randomly looking at it, it's this thing called finite differences. So take two consecutive terms and subtract the second minus the first. The second term minus the first term. The second term minus the first term. And that's your first level, your first differences. And it's not constant yet, so you do it again. And, it is constant. The second differences were constant. It's a second degree polynomial. If the third differences are constant, it's going to be a third degree polynomial, and so on. Once you know that, you can have this skeleton structure here. So you know if in this case, since it's a second degree polynomial, a sub n has to look something like this, an squared plus bn plus c. And then just use the first, second, and third terms to make a system of equations. Use the fact that the first term, when n is 1, is negative 2, and plug those in. There's one equation. The second term, plug that in. Third term, plug it in. There's your system of equations, and then solve using any strategy. Okay, so like I said, if you want to go ahead and stop here and just go into the homework, like you really, or watch the other video on how to use Gauss, I would actually really encourage you guys to do that. Totally optional. You don't need to, but it's very handy. It comes in handy a lot. Anyway, just one more quick example so you can, if you want to try one on your own. So find the nth term for this one. 3, 37, 131, 315, 619, 1073. What? 1,707, 2,551. Holy mackerel, what's going on here? So if you want to give it a shot, see how far you can get, go ahead. And you can pause the video. Hopefully you paused the video and tried it. We're going to go ahead and do it together real quick. So like I said before, you just take any two terms and subtract the second minus the first one. So 37 minus 3 is 34. 131 minus 37 is 94. 315 minus 131, that's 184. I have to admit I did these ahead of time, so that's how I'm doing this arithmetic so quickly in my head. I gave away my secret. 619 minus 315, that's 304. They all end in 4. That's about all I see though. 1073 minus 619 is 454. We subtract the next two, 634. Subtract the next two, 844. Yeah. Nope, don't see it. But anyway, it's not constant. That's really all we care about. So subtract them. 94 minus 34 is 60. 184 minus 94 sorry, is 90. 304 minus 184 is 120. Oh, look at that. 454 minus 304 is 150. There is an obvious pattern here. And finally, we get constants. So this one took a little bit longer than the previous example, but we do get a level of constants. So remember, this first level, these are the first differences. This one is the second differences, but it wasn't until the third differences when we got constants. So the third differences are constant, so that implies a sub n is a third degree polynomial. So what does that look like? Well, that means that a sub n is, we have to start with third degree, but then work our way down until we get to the constant term. That means that there's 4 unknowns here, a, b, c, and d. That means we need 4 equations. I'm not going to write down all the words that I did before, but we are going to do the same thing. We're going to plug in the first term, the second term, the third term, and this time we have to go to the fourth term because we need a fourth equation. So we're going to plug all these guys in and make a system of equations that way. So remember, for the first term, we're going to let all these n's equal 1, and the first term a sub 1 is 3. So it's going to look like 3 is a plus b plus c plus d. Then the second term, we're going to let n equal 2, so we're going to put a 2 in for these n's, and a sub 2 is 37. So we're going to have 37 is 8a plus 4b plus 2c plus d. And we do it again. This time we're going to let n equal 3. We're going to let all these n's equal 3, and a sub 3 is 131. That's 27a plus 9b plus 3c plus d. And then finally, we let n equal 4. The fourth term is 315. And it's equal to 64a plus 16b plus 4c plus d. And this is a system of equations that you need to solve. Now, I am not going to solve it. I will solve it in the other video with Gauss to show you how to use that, and because I don't even want to try this using this method up here where you start taking pairs of equations to eliminate a variable, because basically if you do it that way, what you're going to have to do here is, and it would make most sense to eliminate the d's just because they're easy. You could do something like the first and the second eliminate d, the second and third eliminate d, the third and the fourth eliminate d, but you still have a, b, and c. So you have 3 equations that you get from there. Combine the first and the second for an equation, second and the third for an equation, the third and the fourth for an equation, but you've eliminated D in all of them. Now you take those equations, you can eliminate any variable you want. Let's say if you eliminate C, then it's just a nightmare. So Gauss actually, when you see how it works, Gauss is just linear combination or elimination, whatever you want to call it. It's the method we did above. It's just very efficient and very organized. So I'm going to leave it there, but you would solve this system of equations and fill in your A, B, C, and D, and then you got it. And then just one quick thing. Once you have this, you can see that then A sub n is a polynomial, so then it falls back to the previous lesson. If you wanted to find the nth partial sum, so if you actually wanted to add these terms together and find the sum of the first n terms, now you can use those general summation formulas that we learned last week. And so it kind of all fits together. Look at that. Anyway, that's the end for this. And like I said, definitely encourage you guys to watch the optional video. You have one homework problem that is a 4x4 system. So if you don't do it with Gauss, you're going to have to do it the old-fashioned way. And some people are very good at keeping track of it. But like I said, I definitely encourage you. Take a look at Gauss. That's the end for me, and have fun with your homework. Bye.